Hey, in this video, I just wanted to go over how to graph a few different kinds of exponential functions, mostly just shifts or reflections of the exponential functions that we've typically seen. So I'll start off with just graphing f of x equals 2 to the x minus 1. So we'll start with an axis. And then for exponential graphs, we always try to make sure that we have 2 points labeled. There's 2 important points to label. That way we can determine what the graph is. For an exponential, for the standard parent function of the exponential, we always have 0, 1 on the graph. And then we have 1 comma the rate of exponentiation on as the second point. So that's going to tell us what that base is. So when we plug in, so this will allow us to graph 2 to the x. So when we're graphing something that just looks like 2 to the x, or if it was 3 to the x, we always have 0, 1 and 1, the base. And so by labeling 1, the base, we're able to determine what the function is. So that's why it's important to put that on your graph. All right, now we're actually trying to graph this f of x that's 2 to the x minus 1. And we know exactly how to treat that minus 1. It's just a rightward shift. So it's just like the transformations of functions that we're used to working with. So we'll just put on that, label a 2 on the graph, update the important points. The 0, 1 gets shifted to 1, 1, and the 2, 2 gets shifted to 2, 2. At this point, it sort of looks like it could be a straight line, but remember, it's not. I'll end up looking like this. And there we have it. So that's the graph of 2 to the x minus 1. All right, so now we'll work on graphing f of x equals 1 plus 3 to the x. Again, we'll just start with an axis. We'll label our important points. And we'll need a 4 for later. All right, so again, we have 0, 1 on the graph. And now for the parent function, the base is no longer 2, it is 3. So we'll put 1, 3 on the graph. And then just sketch in the curve. And we'll try to make it look a bit steeper than the 2 to the x, since the 3 to the x will grow faster than the 2 to the x. And now we have to deal with this 1 plus, and that's just a vertical shift upwards, 1 unit. So we'll update our important points, 0, 2, and 1, 4, and just sketch in the same curve, only shifted up. So that's 1 plus 3 to the x, and just sure I'll label that as 3 to the x. So there we go. For our last example, we'll graph 2 times e to the x minus 1. Again, we just draw in a coordinate axis and start to label some important points. So in this case, let's actually do it like this. So we have 1. This is going to be scaled weirdly. We'll call that e. And we'll call that 2e. And then I think we only need a 1 and a 2. All right, so maybe it'd be best to attempt to graph this one on your own, or at least try to start to find the important points of the parent function. All right, well, for the parent function, we of course want 0, 1, and then we want the base, which is now 1, e. And so it's always fine when graphing to just put a tick mark and put e on there, so long as it feels consistent. Like, just remember that e is somewhere around 2.71, so it shouldn't appear above 3 and it shouldn't appear below 2. And then we just sketch in the curve. So that's e to the x. And now we have 2 transformations to make. So the first one we'll handle is this -1. And so that's going to be a rightward shift by 1 unit. So we'll just translate our important points over 1 unit and just resketch the curve. So there we go with that. And then for the second part, we have this times 2. So to figure out that, we're just going to take our important points and just multiply them by 2. So instead of 1 mapping to 1, we're going to have 1 maps to 2. So let's call that 2. We'll have 1 goes to 2. Instead of 2 going to e, it's going to go to 2e. And so now our graph will look something like this. And there we go. So that's how you graph these exponentials. All right, I hope that was informative. All right, see ya.